Hello.
Good evening, sir. Hello, sir.
Yeah, good evening. So, how was your festival?
It was good, sir.
Good. Okay. So, today is there any anything else? I think the festival finished, right?
Yes, sir.
Yeah, good. So, yeah, regarding properties of triangles. So today I will discuss something more about properties of triangles. So, before that, I will ask you some questions. So, did you go through the previous lecture?
Today I did not go through, but I did before.
Yeah. So, simple. I mean, before solving properties of triangles, I always say you should know how to convert sum of two triangle, I mean, like two trigonometric identities into product, like sin A plus sin B. How do you convert this into sum into product of some angles?
Yes, sir.
Yeah. So, how will you convert this sum into product?
1 minute. I wrote it down here.
Yeah. Yeah, it is 2 sin A plus B by 2 cos A minus B by 2. Okay.
Yes, sir.
Similarly, sin A minus sin B is 2 cos A plus B by 2 sin A minus B by 2. Okay, this is how you convert sum into product. Okay, sum of
Yes, sir.
two same trigonometric identities into product of some trigonometric identities. Okay, similarly, cos A plus cos B is 2 cos A plus B by 2 cos A minus B by 2. What about cos A minus cos B is 2 sin A plus B by 2 sin,
Sin A plus B.
yeah,
No, cos A plus B by 2.
sin and sin. Okay, when it is minus you will get sin and sin, when it is plus you will get cos and cos. Okay, just cross check if there is anything different, let me know.
Yes, sir.
Okay, and you also know about sin, this thing you already know, sin A plus B uh, into individual trigonometric angles. Okay, sine of sum of
Yes.
two angles can be converted into individual trigonometric angles, like sin A plus B is sin A cos B plus cos A sin B. Okay,
Sin B
yeah, similarly sin A minus B is sin A cos B minus cos A sin B.
minus cos A sin B.
Yeah, what about cos A plus B?
Cos A cos B minus sin A sin B.
Cos A minus B,
Is cos A cos B plus sin A sin B.
okay, just a second. Oh, okay. Now what is tan A plus B?
It's tan A plus tan B by 1 minus tan A tan B.
Okay, so what is tan A minus B?
And
Okay, you will get minus here plus
tan A
here.
minus tan B by 1 plus, yes, sir.
Yeah. So do you know that yeah, so this is about these things. Okay, you should know fundamental, these are the fundamentals again I'm saying. So without this you cannot solve anything in properties of triangles. Okay, you should always know about this. And the other thing is,
Yes, sir.
I said about sine rule, right?
Yes, sir.
In sine rule, I said a by sine A is equal to b by sine of angle B is equal to c by sine of angle C is equal to 2 times r. Here r is the radius of the circumradius of the triangle,
Circle. Yes, sir.
triangle or radius of the
Yes, sir.
circle. Okay, that is twice r. Okay, suppose this is A, B and C. Okay,
This part we did, sir.
yeah, we did. But how did you got 2r? That thing I didn't explain. So this is, suppose this is the diameter, suppose this is t. Here dB is the diameter, right?
Yes, sir.
Which is 2r. So this is r, then this is also r, and this is also r. Okay, these are all radius. Okay, so basically what I'm saying is a by sine A is equal to b by sine B is equal to c by sine C is equal to twice r. How did you know about this relation already? I'm saying why, how it is related to 2r. I'm saying now, okay, because I didn't explain this thing. So I'm taking two triangles, basically the first triangle and the second triangle.
What, sir?
See here I have taken two triangles and this is the circumcircle for the both the triangles. Okay. Hello? Hello? Can you hear me? Hello? Hello? Hello?
Hello, sir.
Yeah, can you hear me?
Yes, sir.
Okay.
That time I couldn't hear it.
Okay. So in this case what I'm saying is, suppose if you take a triangle and if that is the circumcircle of this triangle ABC.
What, sir? I can't hear you, sir.
Hello, can you hear me now? I don't know, there is network issue here. Okay, just give me a second, maybe if I change the network. Hello, can you hear me now?
Hello?
Yeah, can you hear me now? Okay, I think there is network problem here. Hello?
Hello, sir. I don't know why I'm not able to hear.
Yeah, there is network issue here. I'm in the middle of a remote area like you. But I don't have any, like, I'm using this Geo, this kind of thing. Okay, so
Yes, sir.
can you hear me? Okay, I think there won't be any issue now. So what I want to say is, I said in sine rule or sine law, how you got a by sine A is equal to b by sine B is equal to c by sine C is equal to 2 times circumradius. Okay, suppose this is the circle. If this is the circumcircle of this triangle ABC, if this is the center, then if I have drawn another triangle, okay, that passes through this, and okay, and this, suppose this is a right angle, and this CD, here CD is diameter of the circle, which is twice the radius, right?
Yes, sir.
And this length is common for both the triangles. This BC is common for both the triangles, and in a triangle there is a rule: if there is a common chord, then the angles subtended by the common chord at any point on a circle, this point or this point, are same. That means angle A is equal to angle D, right? That is the property of the circle. For any circle, if this is the common chord.
Sir, is this a different proof?
Not different. No, it is different proof in terms of 2r. Okay, I mean, how you got 2r, that is what I am proving. This proof is right, okay, whatever you got, this is right, I already explained, but you have to know why it is equal to 2r, okay. I will tell you right now, okay, why it is equal to
Okay.
2r. So here in a circle, if I have taken two triangles, this is the circumcircle, and if there is a common chord, here A is the common chord. So in a circle, the common chord subtends equal angles at every point, okay. So this angle and this angle are equal, okay. If both the angles are equal, what is sine of angle A? Sine of angle A is same as sine of angle D if A and D are same, right?
Yes.
If A and D are same, then sine A is equal to sine D. So in this triangle DBC, what is sine D? This is a right angle triangle, okay. DBC is a right angle triangle. What is sine D? Hello? Hello? So
Yes.
what is sine of angle D in this triangle DBC, which is a right angle triangle?
It's breaking, sir. Can't hear
Yeah,
anything.
yeah. Just give some time. Now?
Hello,
Hello?
sir.
Yeah. Okay. Again, that is gone. So again, I am not drawing.
Hello.
So what I am saying
Yes,
is
sir.
sine of angle A is equal to sine of angle D. Okay. Because this is a right angle triangle. Okay. So this is D. So this is A, B, C. Okay. So this is the center.
Yes, sir.
So sine of angle D is what? That is equal to the sides. How it is related to sides?
This. Yes.
Huh? What?
BC by DC.
Yeah, BC by DC. BC is nothing but
BC by DC.
yeah, BC is nothing but
Or small
small a. What is DC? DC is nothing but
a.
2 times radius, right?
Yes, sir.
2 times radius. So from this, what you can prove?
Yes, sir.
Sin A is equal to A by 2R, or A by sin A is equal to 2R. Okay. Similarly, which is equal to B by sin B is equal to C by sin C. Okay, this is the proof. So why A by sin A is equal to 2R? Now you got it. Okay, you can also write A is equal
Yes,
to
sir.
2R sin A.
Yes, sir.
So that is one proof. The other proof is, do you know projection rule? Okay, in projection rule or formula, if you take a triangle ABC, this is A, this is B,
Names.
this is C. Okay,
A is equal to B cos C plus C is equal to
A is equal to B cos C plus,
A is equal to B cos C plus C cos B. That one, sir.
yeah, that one, right. I think this thing you know, I already explained.
Hello,
So
sir.
yeah, so that thing you already know about.
Sir.
Yeah. Hello, can you hear me now?
Hello, sir.
Half angle formula. Do you know what is half angle formula? Hello, hello, hello. Do you know what is half angle formula?
Yes, sir.
Yeah, I think there is some really big problem with this internet. Okay, let me see if this time
Yes.
yeah, if this works or not. Okay, so today and right now I will explain about half angle formula.
Yes, sir.
So half angle formula is simply, so you have to relate some trigonometric identity which is of some half angle like sin a by 2, cos a by 2. These are half angles of trigonometric identities. You need to relate these identities with a, b and c. Okay, sides. So that is
Yes, sir.
that is our target, and I mean that is what half angle formula is, like sine rule, cosine rule and tangent rule. This is also another rule. So to find sin a by 2, what you need to take is, you have to take 1 minus cos a. So what is 1 minus cos a? Or else okay, forget about this. What is cos 2a?
Uh, the
Yeah,
cos cos square a minus sin square a.
right, cos square a minus sin square a. So this can also be written in terms of sin square a as cos square a can be written as 1 minus sin square a, and there is minus sin square a, so this and this will become 1 minus 2 sin square a, right?
Yes, sir.
So if I want sin a, how will you do? 2 sin square a will become 1 minus cos 2a, right? Like that.
Yes, sir.
If I want half angle of this, suppose what about 2 sin square a by 2? I can write it as 1 minus cos a, right? If instead of a I have taken a by 2, then I can write 2 sin square a by 2 as 1 minus cos a.
Yes, sir.
So the same thing I am taking here, 1 minus cosine a is equal to 2 sin square a by 2. Now if I want to relate this sin a by 2 with ABC, you know cos a in terms of ABC by using cosine rule. What is cos a? By using cosine rule, what is cos a in terms of ABC? I mean in terms of sides.
Uh, b b square plus c square minus a square by 2bc.
B square plus c square minus a square by 2bc. Okay, so I'm just expanding. I'm taking RHS later. First I'm taking LHS. So here you can do LCM. So there is 2bc and 2bc minus b square minus c square plus a square, right?
Yes, sir.
So this can be written as, see here, this can be written as minus of b square plus c square minus 2bc plus a square divided by 2bc. So this is nothing but b minus c whole square, right? B square plus c square minus
Yes.
2bc. So I can write it as minus of b minus c whole square plus a square divided by 2bc. This can also be written as a square minus b minus c whole square divided by 2bc. So this is like a square minus b square form. You can write it into two factors, which is a plus b minus c times a minus b plus c, right? A plus b into a minus b, because this is a square, this
Yes,
is
sir.
b square divided by 2bc. So you know that s, there is a term given by Heron where s is nothing but half of the perimeter
Yes, sir.
of a triangle. Okay, so here if a plus, I mean if you want to convert this in terms of s, how can you write? Here you can write a plus b plus c
S.
is equal to 2s, right, from this. So
Yes, sir.
here a plus b can be written as 2s minus c, right?
Yes, sir.
And there is another minus c, so it will become 2s minus 2c into, here there is a and c, so a plus c will become 2s minus b, and there is another minus b, so it will become 2s minus 2b. Here there is a plus c,
Yes.
so a plus c can be written as 2s minus b, and there is another minus b, so that it will become 2s minus 2b divided by 2bc. So I will take 2 common, so it will become 4 into s minus c into s minus b divided by 2bc. So 2 times 2 will, 2 and 2 gets cancelled, and this is equal to 2 sine square a by 2, right? So
Yes, sir.
on the RHS you have 2 sine square a by 2, which is 2 into s minus b into s minus c divided by bc. So this 2 and this 2 will gets cancelled. Then what is sine a by 2?
The sine a by 2 is just
Square root of,
s minus b into,
square root of s minus
oh,
b into
root of s minus b into s minus c by
bc.
bc.
So this is half angle formula. See, where sine of some half angle is related to the sides, okay, where s is half of the perimeter of a triangle, okay. Likewise,
Yes.
sine b by 2 is square root of s minus a into s minus c by ac. Similarly, sine c by 2 is square root of, okay, s minus a into s minus b divided by ab, okay. So this is half angle formula.
Yes, sir.
Now how to find cos a by 2? Okay, cos a by 2 in
Yes.
terms of ABC. So same, instead of taking 1 minus cos a, you know, cos 2a is cos square a, okay, cos square a minus sin square a, right? So here sin square a can be written as 1 minus cos square a, because there is a minus symbol, it will become minus and this will become plus. So cos square a and cos square a will become 2 cos square a minus 1, okay. So to find 2 cos square a, it will become cos 2a plus 1. So because if you want to find half angle, you can write cos 2 cos square a by 2 as cos a plus 1, right?
Yes, sir.
So first you take this one, 1 plus cos a, same thing. So 1 plus cos a can be written as 1 plus what is cos a in terms of ABC by using cosine rule?
It is a b square plus c square minus a square by 2bc.
Oh, minus a square, right here. Okay, so you will get 2bc plus b square plus c square minus a square divided by 2bc. So this will become b plus c whole square, right?
Yes, sir.
Minus a square by 2bc. So this is also a, in terms of a square minus b square. So you can write it as b plus c plus a times b plus c minus a divided by 2bc. So b plus c plus a is simply 2s, and b plus c minus a is 2s minus a minus a, that is 2s minus 2a
Yes, sir.
divided by 2bc. So this 2 and this 2 will get cancelled, so there will be 2 common. So 2 into s minus a divided by bc, that is equal to 2 cos square a by 2. So this 2 and this 2 will get cancelled. So cos a by 2 is square root of s into s minus a divided by bc.
Minus a by bc.
Okay.
Yes, sir.
So this is how you derive. Similarly, cos b by 2 is square root of s into s minus b by ac. Cos c by 2 is square root of s into s minus c divided by ab, right?
Yes, sir.
Now from sin a by 2 is square root of s minus b into s minus c by bc, right? So how to find tan a by 2? Tan a by 2 is simply sin a by 2 divided by cos a by 2. So if you divide this s minus b into s minus c divided by bc divided by square root of s into s minus a by
Into S minus A
bc,
by
so this
BC.
and this and this will get cancelled. So tan a by 2 is simply square root of s minus b into s minus c divided by
C by S into S minus A.
s into s minus a. So this is tan a by 2. Similarly, you can write tan b by 2 and tan c by 2, okay, accordingly.
Yes, sir. Yes, sir.
So this is about half angle formulas. Now, what is area of a triangle? Okay, how to find area of a triangle?
Half
So
into B.
see, there are many formulas for area of a triangle. So if this is the triangle,
So that root of S into S minus A.
yeah,
Minus BS.
we will come to that. Okay, so in triangle ABC, what is in general formula? What is area of a triangle? If I denote delta as the area of a triangle, what is the area of this triangle? Half base into height.
Height.
That is what you know. So here, if I take this is the base, then what will be the height? If A is the base, then what will be the height?
A.
Okay, this is B and this is C. Sorry, this is C. Okay,
You need to draw some.
yeah, this is C and this is B. Suppose this is the perpendicular. Okay, you need to relate, and this is the perpendicular. Okay, how do you find this height? By using C or B, anything.
How to find?
This one. This is the height. How will
Yes.
you find?
How do we find, sir?
Yeah, by using A, this C, angle B, anything. Okay, any of these given properties. Okay, any angle or side you have to use.
Sine.
Sine.
Sine B.
Yeah, sine B is equal to this height. Okay, suppose this is the height. Height divided by what? Because this is a right angle triangle. Because if it is the height, then
C. Small c.
small
C.
c. So height is equal to C sine B, right?
Yes, sir.
Okay, so half A C sine B, which is
Yes,
same
sir.
as if I have taken A is the base, then I can also write half. This is also same as B cos C, B sin C, sorry, B sin C. Okay, similarly AB
Yes.
sin, yeah, or half BC sin A. Okay, so this is okay area of a triangle in terms of A, B, C, and if there is an angle given, this is what it is. Okay, if there is no height given, then you have to find like this, half AC sin B. Now another formula is 2r sin A, 2r sin B. Okay, you know that A is equal to 2r sin A, C is equal to 2r sin C. So you can write it as half into 2r sin A. This one, I am taking this one, any one, you take any one, you will get the same thing. Here I am writing A is equal to 2r sin A, right? Because from sine rule A is 2r sin A and C is 2r sin C and then sin B. Okay, so this
Yes.
this and this will get cancelled, so it will become 2r square sin A sin B and sin C, right?
Yes, sir.
So sin A can be written as 2 sin A by 2 cos A by 2. So if you use like this, it will become 2 into S into S minus B by BC. Okay, 2 by BC into root of this. Okay, so this is how you can write. And also I said area of a triangle is equal to half AB sin C, right? So sin C, see, you know, sin 2A is, or sin 2C is 2 sin C cos C, right? So if I use only sin C here, you can write it as 2 sin C by 2 and cos C by 2. I am relating with half angle formula. So you can write it as 2 sin C by 2 is simply root S minus A into S minus B divided by AB, and cos C by 2 is S into S minus C by AB. So you can write this as 2 by, this will become AB because root AB into root AB will become AB, and you will get S into S minus A into S minus B into S minus C. Substitute this sin C value here. Okay, then what you will get? You will get half AB into 2 by AB into root S into S minus A into S minus B into S minus C. Okay, so this AB and this 2 will get cancelled. So area of a triangle is root S into S minus A into S minus B into S minus C. Okay, this is how this Heron's formula came. Did you understand that? By
Yes, sir.
using
Yes, sir.
half angle formula, we derived this. Okay, so this is another way of finding
Yes, sir.
area of a triangle. Is there any other way? Yeah, and yeah, let's solve some question, because if I say more formulas, you will be like writing more formulas, not any questions. Okay, let's solve some questions. These are the fundamental formulas: half angle formula, triangle, area of a triangle, sine rule, cosine rule, and tangent rule. Okay, if there is anything excess, we will discuss, but these are the main important things. Okay, let's solve some questions. For example,
1 minute, sir. In the textbook, I wanted to.
okay, if there is any other thing, let me know.
Yes, sir.
Yeah, you already sent up to area of a triangle you sent. I already have that book. You send after page number. I will tell you page number also. Just give me a second.
The circle and X circles 392 I need to send.
Oh, okay. Yeah, you just sent up to 382. 382 you already sent it to my WhatsApp, page number 382. After 382, if there is anything else, let me know, because there are a lot of things, so I don't know which one I need to explain. Okay. Yeah, I got. So encircle and excircles of a triangle. Okay. Oh, this is how do you relate encircle and excircle, right? This is somewhat difficult, but
Yes, sir.
yeah. So here area of a triangle is equal to R into S, where R is,
Sir,
yeah, yeah, these things I need to.
a bit more is there. I'm sending.
Oh, yeah, often you
Sir, in
call.
physics, thermal properties of matter.
Yeah,
The topics there.
yeah, you can send that too if you have that text.
The thermal properties of matter, sir.
Yeah, because I want to really teach that thing. Oh, only this incircles and excircles is left, right? Remaining things I think I did explain mostly. Yeah, you can, in meanwhile,
Yes,
you
sir.
can send me those, so I will have a look at it and explain the same to you.
I sent. It's taking some time to load. Sir.
Yeah, it's okay.
Now.
The circle that is passing through DEF is the incircle. Okay. A is an external point of the circle, and AF a tangent drawn. As the length of the tangents AF and AE are equal by a similar argument, PF is Okay, so if you sum up all the things, you will get a plus b plus c. Okay, af plus bc is s, so af is s minus a. Okay, f by f, so r is s minus a tan a by 2. Okay, similarly s minus b tan b by 2, s minus c tan c by 2 from the right angle triangle. UD by r cot c by 2 is dc by r, so so small r is 4r sin a by 2 sin b by 2 sin c by 2. Delta by s is r, r is s minus a into tan a by 2. So delta is equal to s into s minus a tan a by 2. The circle that touches the side BC internally and about two sides AB and BC sectional is called X circle. The circle that touches the side BC. Okay. If I1, I2, I3 are the X centers with radius R0, R1 is. Okay. So the proof of X circles is most difficult. Otherwise, okay. This is going to be like not easy. Even a lot of pages. I thought it is 4 or 5 pages, but you now you have sent me a lot of pages.
Yes.
I think I need to read this because this is really not that easy to prove. Okay. Oh, everything is like given in terms of R. Oh, that's it. So basically what they are saying is, so you also send me the other science photos.
Yes, sir.
But I didn't receive any science, only I received maths.
I will send, sir.
Physics one. I can explain physics, but this maths need to be like this. These are all I forgot these things, so I need to. But I know what that means. Like in circle and X circle, how they are related, and how the area of a triangle is related to. This is basically what they are saying. Okay, this one. So R.
I'm sending now the physics.
Okay, if R is the in circle, So these are X circles. Okay, I don't know how this came. So this is the in circle with radius small r. These are all X circles with radius small r1, small r2 and small r3. Okay, so area of a triangle is simply r into s. Okay, I will tell you the proofs tomorrow. I mean, just I am making you realize that area of a triangle is related to this as r into s, and all r's and r1s are related as 1 by r is equal to 1 by r1 plus 1 by r2 plus 1 by r3. This is how in circle is related to X circle. I will also explain about this. And r1 is equal to, here r can be written as area of a triangle divided by s. Similarly, r1 can be written as delta by s minus a, r2 is delta by s minus b, and r3 is delta by s minus c. Delta is the area of a triangle in all the cases.
Yes.
So this is what we need to prove, and yeah, I think. And also area of a triangle is, because r1 is delta by s minus a, s minus b, s minus c, you can write area of a triangle is r, r1, r2, r3, I think, because if you multiply all the things, you will get delta square, delta to the power of 4 s into s minus a and s minus b. I think it is square root delta to the power of 4 divided by delta square, so it should be square root of r, r1, r2, r3. Then it will be area of a triangle. That is another way.
Yes, sir.
Okay, I think I need to practice a lot for this. So only I mean, if I explain about the in circle and the X circle thing, then everything is got finished. Like, yeah. And yeah, there is a lot of formulas on this. Okay, I will have a look at it, because you need to understand properly, and how to relate in circle with the X circle, that is also another thing. And also r can be written as s minus a into tan a by 2. How that is related, that is also important.
Yes, sir.
Oh, you just sent me. Okay.
I sent before, but it's taking long time to download.
Yeah, because here I have very poor internet. But I can explain this science, okay, if you are comfortable. Thermal properties of matter.
Yes, sir.
There are a lot of things given, but I am not talking all the things. Measurement of temperature, how the temperature is measured, okay, ideal gas equation and absolute temperature. Okay, ideal gas equation is PV by T is equal to mu r. Okay, PV is equal to mu RT, something like that. And so here thermal expansion. Okay, volume at areal and volume expansion, and then yeah, this thing you can do it. Okay, so what is this? Properties of matter, and there is a lot of things given here. Calorimetry, measurement of heat lost by the hot body is equal to heat gained by the cold body. Okay, right. Change of state, a lot of things are given. Temperature and time. Okay, this is very important, temperature and time graph. and this is boiling point, triple point. Okay, and here, okay, latent heat. I can explain. So boiling point increases with increase in pressure. Okay, this I will explain. Heat transfer. Okay, it's a big chapter. I don't know, I thought it is a small chapter, but it's very big. And they have given black body radiation. Okay, greenhouse effect, experimental verifications. In your school they didn't explain this thing, like in your not explained, because it's a big chapter, that's why they left. Even the properties of triangles also, it's a big chapter. Yeah, I can explain you the fundamentals first, and tomorrow we will go much deeply. Okay, so let me share the board. So tomorrow I will explain about this area of a triangle and how this incircle is related to X circle. So here, did you understand what is incircle and what is X circle first of all? So incircle is nothing but it is the circle that touches all the sides of the triangle internally, and this is
Yes.
the radius. Or X circle is, it is exterior to the triangle, but it touches the sides when you extend the sides a little bit longer. Okay, those are the X circles. Okay.
Yes, sir.
So tomorrow
Yes.
I'm going to explain about this. So today maybe I will explain
Yes.
about thermal properties of matter. So why we are studying this thermal properties, and what do you understand by thermal properties of matter or material, whatever it is, matter. Okay, so what are thermal properties? The name says.
Yes, sir.
Yeah, any idea?
Just
Yeah, anything, any idea what is, like mechanical properties and this what you call, we already discussed about mechanical properties of fluids and mechanical properties of solids, right?
yeah, whatever heat changes happen.
What?
Heat.
With heat, yeah. So when you heat something, how the changes happens in the material. Yeah, that is the exact definition. Okay, thermal properties are nothing but these are the properties of the material when you apply heat or change the temperature of the material, how the material behaves. That is what we are going to study. Okay,
Yes, sir.
that's, yeah, whatever you said, that is the right definition. And the other thing is, so in your real life, what did you explain about this heat, like how the properties, how did you physically are seen with your eyes? So with heat, what are the things that got changed?
When
Anything.
ice becomes water,
Yeah,
and
very good.
food is being cooked.
So yeah,
Anything is irritated and burnt.
yeah. And is there any?
And wax candles are melting.
Good.
And they said,
At least you should give me 10 examples, because everywhere there is heat. Okay.
yes, sir.
Even if you are eating an omelette, so the liquid, initially the whatever the egg, that is a semi-liquid, and it becomes into white color thing, right, after heating. So there is some changes.
Yes.
And what happens to the milk when you heat after some time?
Yes, sir.
See, when you, I will
Can
give
you
you,
again, sir?
see, when you keep a milk, when you are boiling a milk, So after some time you left the stove like that. So what happens to the milk?
Yeah, it'll
Hmm?
come up.
Come out.
It'll come up
Yeah, it will come out. Why it is coming out?
because that liquid molecules, because of heat, something will happen to them.
Yeah, something will happen. So basically there is an expansion there. Okay,
Yes.
the milk is getting expanded when you apply the heat. So because of that expansion, its volume getting increased. So hence, so when the volume gets increased, obviously it will come out of the bowl. Okay, so that is one observation. What about your when you get a fever? What happens when you go to the doctor? How he will check?
You put thermometer.
Sorry. So how will you check with thermometer? So what happens to the thermometer?
It will get the heat and keep inside our mouth.
Yeah. How you will say like you have some fever or not?
If there is more heat than the normal heat,
Yeah.
normal body heat.
Yeah. Obviously that's right. But how will he check with that thermometer? He will look at this thermometer, right? So what?
Yes, sir. The
What?
number should show.
Yeah, exactly. So there will be a reading, right? So basically,
Yes, sir.
there will be a reading. Basically, inside there is a mercury. So basically, when you, I mean, keep inside your mouth, what happened is because of that heat, the mercury gets expanded. Like milk, the mercury will gets expanded till some height. Okay. So according to the temperature, it will increase its length. Okay, it will expand and increase its length inside the thermometer. So accordingly he will see, okay, if you have more temperature, then then the mercury will expand more. If you have less temperature, then it will be at normal temperature. Okay,
Yes.
like that you will know whether I mean the doctor will know you will have a fever or not. Okay, so do you know about any temperature scales? I mean how the temperature is measured?
Kelvin and Celsius.
Yeah, Kelvin and Celsius. So and also there is a Fahrenheit scale also. Fahrenheit.
Yes, sir.
So if you go to, I mean,
Yes, sir.
in most of the thermometers are
Yes, sir.
Fahrenheit thermometers, and if you go to US, they
Yes,
only
sir.
follow Fahrenheit or Kelvin. They won't
Yes,
follow
sir.
Celsius.
Yes, sir.
Yeah. So, okay. So starting from what we have to start. So okay, ideal gas equation. So, okay, before going to ideal gas equation, okay. So they explained about something. Maybe I will have a look at it so that I will teach you accordingly. Oh, you already sent me all the things. Okay. Hello. Hello. So what is the difference between a temperature and a heat?
Yes, sir. Temperature is a measure of heat.
Yeah, measurement of heat. So what is heat then? Yeah. So then what is heat?
How do you define it, sir? It's just a form of energy.
Yeah, that's right. So heat is a form of energy. Okay. So heat is a form of energy. That gets transferred from one body to the other body. I mean when they are in contact. Okay, if there is a heat is getting transferred from, it is a form of energy. First of all, it is getting transferred from one body to other body if there is a contact, and also if there is a temperature difference. Okay, temperature is a measurement of heat, okay, in some degree Celsius. If it is T1 is greater than T2, then there is a heat energy that is going from this body to this body. Okay, always from high to low. Heat travels from high to low, right? That is the
Yes, sir.
universal law. High energy to low energy, always energy flow from high energy to low energy. Okay, so here heat is a form of energy that travels from one body to other body if there is a temperature. Hello, hello.
Hello, sir.
Yeah, can you hear me?
Yes, sir.
Okay, so what I said, heat is a form of energy that transfer from one body to other body if there is a temperature difference. Okay,
Yes, sir.
for example, if there is a body A, suppose this is ice cube, okay, and this is the surroundings. So what happens to this ice cube?
It melt according to the temperature
Yeah,
slowly.
so what happens to this ice cube? So what is the temperature of this ice cube and what is the temperature of the surroundings? First of all,
One of the side ice cube is less, very less.
huh? Which one will be more and which one will be less?
The ice cube will be less, sir. It will
Yeah,
be
so
0 degree
it is 0
Celsius.
degrees or less than 0. Okay, whereas surroundings temperature is mostly it is 20 to 30 anywhere.
Yes, sir.
Okay, mostly it is 23 or 20 to 30 anywhere, so it is more than this temperature. So here there is a temperature difference. That means what happens? If there is a temperature difference, what happens? So there is a heat in the surroundings,
It
right?
will melt. It will melt, sir.
Yeah, it will melt. How it will melt? Okay, so there is some process.
Hello,
Okay,
sir. It will melt.
yeah, it will melt. So how it will melt? So there is a heat here,
Yes, sir.
so this heat will transfer from surroundings to the ice cube. Okay, so if the heat gets transferred, that is nothing but now it is trying to make this what your surrounding temperature to the, I mean ice temperature to the surrounding temperature to get balanced. Okay, so in that case this gets heated, and when the ice gets heated, this
Yes, sir.
this will try to increase and it will melt and become water. Okay, so that is one way of transfer of energy or heat
Yes, sir.
if there is a temperature difference. So what happens, suppose you take hot cup of milk. Okay, it's very hot, so that the vapors are coming. So you put a metallic teaspoon. What happens to this teaspoon after some time? Okay,
It might expand a little.
oh, yeah, come on, you are not boiling. Okay, you just took some hot milk in a cup of glass.
Nothing will.
Okay, it is very hot, it's not boiling. Okay, I mean you already boiled and you have taken inside a cup. Okay, now it is, you put it on a table. Now what you want to do is you want to mix some sugar, so you kept a teaspoon and left it like that. Okay,
Yes, sir.
teaspoon is metallic. Okay, So initially the teaspoon is normal temperature, okay, like the surrounding temperature 20. So what happens to this teaspoon after some time when you put it in a hot milk? Hmm? What? Yeah, tell me. You're right. I mean,
Heat up. It will heat up.
yeah. So it will heat up. Okay. So its temperature will increase. So it will become more than 20, some 30 or 40 according to the milk's hot temperature. Okay. So basically heat will transfer from here. The milk is having more than almost 80 degrees or 90 degrees Celsius temperature. So now the milk is hot and the spoon is cold. So heat will transfer from milk to the spoon, and also from here to here also it will transfer. Okay, so the handle will become hot. Okay, when you touch the teaspoon you feel it very hot, right? Okay,
Yes, sir.
even you when you cook, I mean, if you observe it or not, so when your mom left your utensil, I mean this spoon inside this bowl, and when it is getting cooked, so when you touch this spoon, your hand will
It will hot.
melt. Okay, I mean you will get a burns. Okay, it will become very hot. Why? Because heat is transferred from this bowl to the teaspoon to this handle. Okay, even though it is not touching, still heat is getting transferred
Yes, sir.
from bottom to the top of the handle. Okay, okay. So these are the examples to make, I mean, in real life examples. So now, so how to measure heat? So basically you say some body is hot or cold by touching it. Okay, so by touching it you can say whether a body is hot or cold, right? So because there is a
Yes, sir.
temperature difference, then only you can know whether it is hot or cold. Okay, suppose if some body is having more temperature than you, when you touch it you will feel hot. I mean the body will be a little bit hot. When some body's temperature is less than your temperature, then if you touch that body, you will feel like cold, right? So to measure what
Yes,
temperature
sir.
the body is, the scientist gave you some scale like in degrees Celsius and Fahrenheit scale and also Kelvin scale. Okay, so there is 2 points. One is ice point and
Yes.
boiling point. Okay, ice point is nothing but where the water gets melted. I mean,
Yes,
not
sir.
melted, it becomes solid. So that is the ice point. Okay, so for water it is 0 degrees Celsius. So I am taking only for water. Okay, and for boiling point means where the
Yes, sir.
water gets boiled, means it becomes and I mean the water will exactly after heating it will become
Yes.
vapor. Okay,
It's
water will
starting
become
to
vapor.
vaporize.
Yeah, it will become vapor. So it is 100 degrees Celsius.
Yes.
So in case of Fahrenheit it is minus, I think it is 32 degrees is the ice pointer in terms of Fahrenheit. Okay, and to boiling point is 212 degrees Fahrenheit. So in Kelvin scale the ice point is 273.15. You can neglect this Kelvin, and boiling point is 373.15 Kelvin. Okay, so this
Yes,
is
sir.
for water. So these are three different like units. So these three are three different scales. So in degree Celsius scale ice point is 0 and boiling point is 100, and in foreign heat scale ice point is 32 and hello. Okay, hello.
Yes, sir.
Okay, so did you understand what I said?
Yes, yes, sir.
Yeah, so in degree Celsius your ice
Yes, sir.
point, my internet connection is not stable.
And boiling.
Okay. So in degrees Celsius, ice point is 0 degrees Celsius and boiling point is 100 degrees Celsius. In Fahrenheit scale, it is 32 and 212. And in Kelvin scale, the ice point is 273 and boiling point is 373. Okay, and there
Yes,
is
sir.
absolute zero. Absolute zero means, so this Kelvin scale is called absolute scale.
Yes, sir.
Absolute scale means all the formulas, wherever the formula you use, I mean the relations, you always take the temperature in terms of Kelvin. Okay, I mean you have
Yes,
to
sir.
convert whatever may be the scale it is given, you have to convert that into Kelvin scale, and then only you have to use that value in formulas wherever you use. Okay, when there is some relation with temperature. Okay, so this is the absolute scale.
Yes, sir.
um, so so the absolute zero, zero, or in Kelvin scale is, I mean the least temperature in Kelvin scale is minus 273.15 Kelvin. Okay, so this is absolute zero. I mean this is the zero scale of
Yes,
Kelvin,
sir.
like when you draw the temperature versus, I mean, so this is the boiling point and this is the temperature, which is minus 273.15 Kelvin, and this is ice point, which is 273.15, and this is
Yes, sir.
boiling point, which is something, I mean this is minus 273.15 and this is 273.15 and this is 373.15. Okay, this is the point where absolute zero means here everything will freeze. Okay, nothing will move inside the object, it will be at rest. Each and every particle will be at rest. In general, at a particular temperature, no particle will be at rest. Okay, it moves randomly, I mean, but that movement you cannot observe with the eyes. But like if you boil the water, you know, the water will like jump, right? I mean, whatever what you call, you will observe some bubbles coming in the water or milk when you boil it, right? So inside there is some movement of the
Yes.
particles when you increase the temperature. Likewise, even at low temperature also there is some movement of particles, but that is very very negligible and you cannot detect with the eye, but there is a movement. So at absolute zero means minus 273.15 Kelvin, you won't have any movement and everything will freeze. And till now, no one achieved this absolute zero temperature. Okay, it is impossible to get absolute zero. Okay, that's the ideal case.
Yes, sir.
They I mean they got close to minus 200 something like that Kelvin. Below that they never went. Even minus 200 Kelvin is also, I'm not sure, but they never went to the this much temperature. This is like when you have, I mean when you draw this temperature scale, it will touch here. Okay, so this scale is, they shown it as absolute zero. So how to relate degree Celsius and Fahrenheit and Kelvin scale? Okay, so if I have given something in degree Celsius, how to convert that temperature into Fahrenheit and Kelvin scale, or Kelvin into Fahrenheit or degree Celsius scale? So there is a relation. Okay, so suppose if I have given some temperature in C degree Celsius, okay, so I want to convert into Fahrenheit, then what you do is you subtract this C degree Celsius with the ice point of the this C. So what is the ice point in degree Celsius? That is 0, right? Divided by
Yes, sir.
boiling point of that Celsius scale, 100 minus ice point, is equal to same thing here. So that is same as, you know, the temperature that you want to find is F. Okay, F is the Fahrenheit scale, that is the temperature at which degree Celsius can be converted into F. Okay, so the body is that the body's temperature is F. We have to find by relation. Okay, that F minus ice point in Fahrenheit is 32 divided by
32.
212 minus 32. Boiling point in Fahrenheit minus ice point in Fahrenheit is same as in Kelvin scale. Suppose K is the temperature that you are going to get, then
Yes, sir.
K minus ice point is
270.
ice point is 273.15. and boiling point is 373.15 minus ice point is 273.15. So if I have given degrees Celsius, suppose your temperature is 30 degrees Celsius, how to convert this into Fahrenheit? How to convert this into Fahrenheit? Can you convert by using the given relation?
Yes, sir.
So what you will do?
30 minus 0, sir.
Yeah.
Minus 32 by 212 minus 32.
Yeah. Yeah. You can do it on the top.
If you cross multiply, yes.
Yeah.
212 minus
32 is 180, I think. That is 180.
180, yes.
Mm.
So 30 into 4. Nothing more.
That is 3200, okay? Because 100 into f minus 32 is 100 f minus 3200.
Yes, sir. I can't write it there, no, sir.
Okay, okay. So 5400 plus 3200 is how much? 54 plus 32. 86. 8600.
It's 8600.
So
So
8600.
86 Fahrenheit.
So 86 degrees Fahrenheit. So 30 degrees Celsius is same as 86 degrees Fahrenheit. Very good. So how to convert that into Kelvin scale?
Yes.
Same 36 30 degrees is
86.
yeah, that is Fahrenheit scale. Yeah, you can use any two. I mean, it is not necessarily you have to use these two. You can use these two also. You will get the same answer. Yeah, go ahead.
Yes. 180. And then here is 317.
ఏం చేసా
373.
Yeah.
Hundred A into, sorry, minus. Sorry. 7315.
Okay. Right.
Yes.
So you will get something. I mean, I think you will get 30 means 303.15 you will get.
Yes, sir.
You will get something like 303.15, something like that. Kelvin. Okay. So this is very important. You can note it down. Did you note this formula? This is very important. This one.
Written here 3 into 7.
Oh no, you. I think you should get 303 point something. So I will tell you how. So if I equate these two, so I am writing here C by C is nothing but 30. 30 divided by 100 is K minus 273. I am just taking 273 to make the calculation easier. 373 minus 273 is 100. This 100 and this 100 will cancel. So K is 273 plus 30, which is 300 point something. Okay, so you will get around 300 Kelvin. What?
It's even when I did it in Google, it came 86 Fahrenheit is 303.15.
Yeah, sorry, it is 303 because 273 plus 30 is 303. 303.15 because I have not taken here 15, so you will get 303.15. Yeah. Okay. Did you understand
Yes.
that?
1 minute, sir. One call is coming. Just 1 minute. Sorry, sir.
Yeah, you can have that call. I will wait for you, don't worry.
Yes, sir. Sorry, sir. They didn't know I was having class.
Oh, okay. So you
told
I mean, this is the time for your dinner, right?
No, sir. Someone called me. My grandfather called me.
Oh, okay.
He doesn't know.
Oh, okay. No, you just say I will talk to you later, then it will be fine.
I told him, sir.
Oh, okay. Then it's fine. So where we are. So now you know how to convert one scale of temperature into different scale of temperature. Okay.
Yes, sir.
So there is an ideal gas equation. So why this ideal gas equation means? So you take any liquid or any object or anything in a.
I know the ideal gas equation, sir.
Yeah, what is that equation? This is always
PV is equal to nRT.
yeah, PV is equal to nRT. This is also there in chemistry, I think.
It's in yes, that
Yeah.
only yes, sir.
Yeah. So can you tell me why ideal gas equation? Why we are learning about this?
Because we want to study the gas when it has least pressure,
Yeah. Right.
or
So
want
what?
to know how much
Yeah.
deviates from real gas.
Exactly. Right. Very good. So basically, so every not only gas, anything. So this is ideal gas equation. This is ideal means you cannot achieve this gas. I mean this equation, but this is like a benchmark for all the gases. Okay. We compare with this equation. Basically, what happens is every gas at any time will have some pressure, volume, and temperature in not only gas, any object, right?
Yes, sir.
Any object in the universe will have some pressure, volume, and temperature. So when you change any of this property, the other properties will also change. So there will be some relation.
Yes, sir.
Okay, there will be some relation. That relation is nothing but this relation. Okay, that relation came by this, even like by changing the temperature, how the pressure is behaving. Experimentally they have done, and also by changing volume, how the pressure is changing, and also by changing temperature, how the pressure and volume changing. Like that, they measured some values and they found out that pressure into volume is equal to temperature. I mean that is directly proportional to temperature, or nRT, where R is gas constant. Sometimes you call it as universal gas constant.
Rydberg's, yes, sir.
So universal gas constant. So its value is constant, that is 8.314 kilojoule per kg, something like that. I don't know exactly what's that value. Kilojoule per Kelvin mole, whatever. You will have that constant value. Okay. So from this relation,
Yes,
what
sir.
what you can say, so the very important thing is, so this is the ideal gas equation. So PV is equal to nRT. So
Yes, sir.
so at constant temperature, if I increase volume, what happens to the pressure? So temperature is constant. So if I increase volume, what happens to the pressure? Whether it will decrease or increase or stays the same.
At constant temperature,
Hmm.
if we increase the volume, the increase the volume, sir.
Yeah, if I increase the volume of the gas, what happens to the pressure?
It will increase.
How? See, very simple. PV is equal to nRT, right? So P is equal to nRT divided by V. Okay. So now I said temperature is constant. So temperature is not changing. So that means this is constant. R is always constant. Suppose N is also constant. N is also same gas. So N is also constant. So this is a constant value, this entire thing. What I am saying is, if I increase the volume, what happens to the
Oh,
pressure?
it will decrease the pressure. Decrease the
Yeah,
pressure.
so the pressure will decrease. Okay, that's what very important. So ideal gas is important for this. So if I at a constant temperature, if you increase the volume, pressure will decrease. What happens when I decrease the volume at constant temperature? What happens to the pressure?
At constant temperature, the pressure will decrease.
Volume is decreasing. What happens
Oh,
to the
volume
pressure?
is decreasing, it will increase. Sorry.
Pressure will increase. Okay. Now at constant pressure, mhm, if I increase the volume, what happens to the temperature?
It decreases.
Again, look at the relation. So what I said, PV is equal to nRT. I said pressure is constant. Okay. So you need to relate
Yes, sir.
volume and temperature. So I said volume is increasing. So what happens to the temperature?
Yes, sir.
So this is constant,
Temperature also.
increase. So if this increases, because there is a direct relation, temperature will also increase. Okay.
I
Similarly,
told that only, sir. But
oh, oh, you said temperature increase. Okay, okay. Sorry, I thought you said decreased. Oh, then it's fine. If
yes.
similarly if volume is constant, if I increase the temperature, what happens to the pressure?
Mhm. Time is gone. Pressure will increase.
Increase, because PV is equal to
Yes.
nRT. So if volume is constant, pressure is directly proportional to temperature. So if temperature increases, pressure increases. Okay. So this is what happens inside a cooker. Okay. Inside a cooker,
Yes.
pressure cooker, what happens? So volume is constant because you are fixing the volume, means you are closing the lid and this is the only volume you have. So but if you increase the heat, I mean if you supply the heat, temperature increases, because of which pressure also increase. So if you have the more pressure, then the excess pressure will come out and the food will cook.
Yes, sir.
Okay. So there are a lot of applications. So this is how the importance of the one of the application of this ideal gas equation.
Yes, sir.
And yeah, regarding boiling point, so what happens to the boiling point when you suppose when you are on the top of a hill? So this is a hill, so here the boiling point is T. What happens to the boiling point at the top of the hill? Will it increase or decrease or stays the same? Boiling point is nothing but the temperature at which it boils. So what happens to the boiling point of any substance when you move from ground level to the top of the hill?
The boiling point will increase.
How? And the thing is, see, there is a, see, I said, I never said the conditions. I gave a condition: at the ground your pressure is more than the pressure at the top of the hill. Okay, I mean pressure is decreasing, P1, and this is P2. When you go to the top of the hill, P2 is less than P1. Okay.
Oh, okay.
Okay, so what happens to the temperature now? Can you tell me? Pressure gets decreased when you move from ground level to the top of the hill.
So if pressure decreases,
Yeah.
temperature decreases.
Yeah, temperature decreases, so that means boiling point decreases. Okay,
Yes, sir.
boiling point decreases means if you cook something on the top of the hill, it will get less temperature. Okay, so that it won't cook that much faster, it will take a lot of time. Okay, because it won't take that much heat, it boils at less temperature. At less temperature it boils, it is not taking that much heat, means it cannot cook that early, it will take a lot of time. Okay, even not only that, even our body also will not you will observe some breathlessness when you
Yes, sir.
move on the top of a hill. Okay, because of the pressure changes, you won't breathe properly. So sometimes, some people who are climbing the mountains, so they will because of this pressure difference they can't breathe properly. So basically what happens is this oxygen supply will decrease, and so blood is coming from the nose sometimes. Hello?
Hello, sir.
Yeah.
Yes, sir.
So did you understand what I said? There is a lot of application of. So what I am saying is, if there is a pressure decrease when you move from ground to the top of a hill, what happens is, because of this pressure difference, you can't breathe properly. So because of it, there is oxygen levels will get decreased inside your body. So sometimes, the one who climbs on the mountain, some blood is coming from their nose. Okay,
Yes, sir.
because of that. Okay, not only that, even your skin will become red sometimes. Okay, when you are like foreigners, easily you can observe, because they are white, and so even if they climb mountain, their skin will become red easily.
Yes.
Yeah, because there is some blood is pumping out. Okay, because of some pressure difference. Okay, so this is ideal gases equation is useful to find these kind of things. Okay, now, so I said milk, when you boil a
Yes.
milk, it gets expanded, right, and it will fall out. So after some time,
Yes, sir.
at boiling point, it will get expanded and it will fall out. Okay, so what happens, do you observe anything like okay, so your door, take your door. Okay, so there is an iron door here. Did you observe the iron door become tight
Yes, sir.
in summers
Yes, sir.
and loose
Yes, sir.
in winters?
Because
Why this is happening? See, sometimes when you apply the door
yes, sir.
during winters, it will be like loose, you can easily apply the door, but during summers it is tight. Why?
Because in summers the metal will expand because
Exactly.
of heat.
Yeah, because of heat there will be some expansion in the metal, because of which the actual, because there is some restriction here, what we call
Yes, sir. Such
uh,
as
yeah,
railway tracks also
yeah,
they will
yeah, so they will try to expand, so they will become
have
tight, and
space
when you apply
between.
the door it is very very, you have to apply a lot of force, and you have to apply. That's why we use wooden doors, because wooden doors won't expand that much compared to iron doors. Okay, so mostly we use wooden doors at your home. Why? Because wooden doors won't have that much effect with heat. Okay, they won't expand or contract that much, but iron doors will expand during summer and becomes loose during winter. Okay, so there will be gap, you can see there will be a gap in between here during winters, but there won't be any gap during summers. Okay, so why? Because it is getting expanded due to heat. Okay, so there will be,
Yes, sir.
if you take a wire, so if you heat this wire there will be linear expansion. So linear expansion means only the length will increase.
Yes, sir.
So it will get increased to L2.
Yes, sir.
So if you take a plate, so if you heat this plate, what will happen? Okay, what will happen?
There will be expansion on all sides.
So what is increasing? So here length is increasing, so in this case what is
Here area.
area is increasing, so there will be areal expansion or area expansion, whatever you call. Okay, so area is getting increased. Suppose final area, this
Yes.
area is A2 and this area is A1. Suppose you take a bowl of milk. Okay, good example. So when you boil it, what happens? It gets expanded, right?
It will expand.
So initially the volume is V1, finally the volume is V2. So there will be volumetric expansion or volume expansion, whatever it is. Okay.
Yes, sir.
So the percentage or the fraction of expansion is how you can calculate linear expansion here. Okay, just give me a second.
L1 my L1 L2 minus L1.
So what is percentage of linear expansion? So that is change in length divided by original length, right? So this is the percentage or fraction of thing that is expanded. If you multiply with 100, that will give you percentage, otherwise it will give you fraction, right? Hello?
Yes. Yes,
Yeah.
sir.
So the percentage increase
Yes,
the percentage of fractional increase in areal expansion is final area minus initial area divided by original area or initial area. Similarly, so I can call it as delta A percentage, delta V percentage. So which is final volume minus initial volume by initial volume, that will give you percentage increase in volume. Okay. So for each material there is some coefficient. Okay. So because there will be some constant or there will be some relation. So definitely if you heat it, it will increase its length. If you cool it, it will decrease its length. Okay. If you cool, definitely it will decrease
Yes,
its
sir.
length. Likewise, if you cool, it will decrease the area. Likewise, if you cool it, it will decrease the volume. Okay.
Yes, sir.
like this. Okay, this is happens vice versa, and each material will have a coefficient, so that is a constant of with the material. Okay, here there will be linear coefficient of expansion alpha. Okay, that is
Yes, sir.
alpha is nothing but percentage or fractional change in this thing, that is L2 minus L1 by L1 with respect to the unit change in temperature or increase in temperature. Delta T is nothing but T2 minus T1. Okay, for unit change in
Yes, sir.
temperature, how much fraction it is getting expanded linearly, that is nothing but linear coefficient of expansion. Okay, and its units are per degree Celsius or per degree Kelvin, whatever it is, because here meter per meter, centimeter per centimeter will get cancelled, there won't be any units on the numerator, but in denominator there is a temperature difference, so there will be degree Celsius, so it will per degree Celsius or 1 by degree Celsius. Similarly for this one, so beta is coefficient of areal expansion, which is a constant for a particular material. Okay, so that is A2 minus A1
Yes,
divided by
sir.
A1. So fractional increase in area with increase in temperature or unit increase in temperature. Again, these units are 1 by degree Celsius. Similarly, fractional increase in volume, gamma, I call it as gamma, is the coefficient of volume expansion, which is change in volume divided by original volume per unit increase in temperature. Again, these units are 1 by degree Celsius. Okay, this is constant for a particular material. For this milk it is constant, for this whatever plate, for example it's a steel plate, for beta is constant for steel plate. If it is iron wire, so for iron it is alpha is constant. Okay, so these are coefficient of expansion. Okay, so how these three are related, alpha, beta and gamma for same material. So these three are related like so. Alpha is changing linearly, beta is changing in two ways, right, in two directions, in this direction as well as this direction, whereas gamma is changing in all the three directions, right, x, y and z.
Yes, sir.
So if alpha is changing one time, beta is changing in two directions, so you can call it as
Yes, sir.
2, and it is changing in three directions, so it is 3. So the ratio is 1 is to 2 is to 3. Okay, hello.
Hello, sir.
So the ratio is 1 is to 2 is to 3.
Yes, sir.
Did you get it?
Sir, can I use the washroom?
Yeah, sure.
నైట్ నైట్ వరకు చెప్తాను. నాకు కూడా కొంచెం ఇంట్రెస్ట్ వచ్చింది నీతో మాట్లాడుతుంటే. ఓకే ఓకే, నేను ఇప్పుడే చెప్తాను నీకు చేయి. అంటే 9:30 వరకు ఫోన్ చేసి చెప్తాను. జీసీ 2 ఇయర్స్ ఉన్నారు.
జీడీసీ ఎప్పుడైనా రాయొచ్చు.
ఎవరు చెప్పారు?
నువ్వే చెప్పావు కదా
2
జీడీసీ.
ఇయర్స్ ఉన్నావా?
ఓ, హలో. Hello.
రేపు చేపలు మిస్ అయ్యాను బ్రో.
మన ఫుల్ కొమ్మచ్చు.
Sorry, sir. I went to drink some hot water also.
Yeah, sure, take your time. I mean, even I am also using something else. Okay. Yeah.
Sir, can we continue the class tomorrow?
Yeah, sure.
Because after this, after dinner again, I have another class.
Oh, you have a class again. So tomorrow at what time? Tomorrow evening is fine, or
Morning, sir.
morning 8 o'clock is
Anytime, sir.
8 o'clock.
Yes, sir. Yes, sir.
Okay. So I will continue class at tomorrow. Okay. Right.
Yes, sir. Thank you, sir.
Bye.